Stay on top of emails, documents.
Good morning, sir.
Good morning, ma'am.
Good morning, sir.
Good morning. Children, what did we discuss in the last class? Tell me.
Factors affecting the equilibrium constant.
So, among them, which one is completed?
Stoichiometric coefficients of reactants completed, sir.
Stoichiometric coefficient is completed. Here
Yes,
not.
sir. And direction or mode of reaction also completed, sir.
That is also completed. Okay. So, shall I give the one more model problem? Can you solve this one? So, that next is multiple steps. Next factor is multiple steps. Multiple steps. Right, children. How the multiple steps are affecting this? Okay, let me discuss now. For the example, A is equilibrium with B. Then, for this reaction, equilibrium constant is taken as K1. Now, B is equilibrium with C. For this reaction, K2. C is equilibrium with D. For this reaction is K3. Now that overall reaction, that it is A is equilibrium with D in single step. Then equilibrium constant is K. Now observe, children, this is the K is equal to, how it is related with this one? K1 into K2 into K3. Children, it's clear now? Ma, it's clear?
Yes, sir.
So for multiplication steps, more than, for the example, what I am taking, children, H3 PO4 is equilibrium with H plus H2 PO4 minus. For this one is K1. And the reaction H2 PO4 minus is equilibrium with HPO4 minus 2. For this reaction is K2. Now HPO4 minus 2 is equilibrium with PO4 minus 3. PO4 minus 3. For this one is K3. Now that overall reaction, children, just wait 1 second. Right, children. So for the total equation that it is H3PO4, H3PO4 is equilibrium with 4H plus 4H plus, sorry, I did mistake. 3H plus PO4 minus 3. For this reaction is K. Okay, how they are interrelated with these, that it is K is equal to K1 into K2 into K3. Children understand, Amma? Children understand now? It's clear? Ma, tell me please. It's understand now? Concept. Children, concept is understand now?
No, sir.
Understood, sir.
Right. Now, I am giving the one critical model problem, children. Solve it. Copy now? Copy now?
No, sir.
Yes. My question is, first question is myself, that it is A is equilibrium with B. For this one equilibrium constant K1. Now again C is equilibrium with B. This is K2. Now C is equilibrium with D. This is K3. Now find K for the reaction is D is equilibrium with A. Is
Sir, K2 by K1 into K3, sir.
This is tell me.
Sir, K2 by
K2 by
K1 into K3.
is equal to K. Children, anybody in the class? Banu? Banu?
Sir, same option, sir.
Same option. Children, anybody in class? So many students are in the class. Vasavi,
Sir,
Akshita,
K1 into
Prabha.
K3 by K2.
Ma?
Inverse, sir.
It's inverse.
Yes, sir.
K1 into K3 by K2 is equal to K. Is anybody in the class? Children, tell me. Priyanka, Rakesh, Uma Prasad. Children, what is your answers? Tell me, don't waste our time, please. I am solving the problem. Now, to get this one, D2A. D2A. D ఎటువైపు రావాలి తల్లి మనకి ఇన్వర్స్ రావాలి. This is D2A. D is equilibrium with A. Means D ఇటువైపు ఉంది కదా ఇన్వర్స్ చేస్తున్నా. That it is K3. 1 by. Now, ఇక్కడ చూడండి తల్లి A కూడా ఇన్వర్స్ ఉండాలి. Okay, no? B is equilibrium with A. Okay, its value is inverse, that it is K1. Okay, now ఈ ఈక్వేషన్ ని మనం క్యాన్సిలేట్ చేసుకోవడానికి ఇన్వర్స్ చేస్తున్నా. B is B, so this is as it is, right? C is equilibrium with B. Okay. Now under C is there, na? C is equilibrium with D. This is K2. A is equilibrium with B. K1 inverse value. C with B. Right, okay, as it is K2. Next. First equation in just this is B2A, D2A kada. This is the inverse value 1 by K1. Okay. Next BB cancel చేసుకోవడానికి నేను as it is రాస్తున్నా. As it is if I write as it is. So this is K2. So next D2A inverse value. D2C
1 by K3.
is 1 by K3. All right, children, on summation. So BB cancel for the example. CC cancel. Now D2A is equal to K on adding the equation. K2 by K1 into K3. Children, it's clear now? Are చెప్పరా?
Yes.
Yes, sir.
Yeah. So another model critical condition I am giving children. One more model I am giving. Solve it. Copied now? Copied now?
Yes, sir.
Right. Right, children. I am giving now one more example for this one. 3B, my next question. 3B is equilibrium with 3A. 3A. 2C is equilibrium with 2B. Now C is equilibrium with D. Okay. Now this is K1. This is K1. This is K2. This is K3. K3. Then find D2A is equal to K.
Sir, 3K2. Sir, 3K2 by 2K1 K3.
Once again, tell me.
Sir, 3 into.
3 into na?
Yes, sir.
Ah,
K2, sir. 3 into K2 by.
not getting. నాకు సరిగ్గా అర్థం అవ్వట్లేదు మా వాయిస్. Varshit? Okay. Banu, did you solve now? Banu. Okay. Anita?
Sir, I posted in the chat box. I posted in the chat box.
Children, tell me. Abhikiran. Akshita, Abhikiran, Angel. Wow, time is. Vasavi. Vasavi.
3K1 into
Completed,
2K2.
na? Ma?
3K1
3K1
into 2K2
2K2
by K3.
by K3. Okay, children, I am solving D2A. So its value should be inverse. I am writing D2C is 1 by K3. Now C ki as it is note cheyadame. Okay, 2C is equilibrium with 2B. Okay, so 2C ni ఈ ఈక్వేషన్ ని మనం ఇది రావాలి అనుకుంటున్నాం. ఈ ఈక్వేషన్ రావాలి మనకి, దీని నుంచి ఇది రావాలి. ఓకేనా? రావాలంటే దీన్ని ఎంతతో మల్టిప్లై చేసిందన్న 1/2 into 1/2. Now 2 cancel, 2 cancel. ఈ ఈక్వేషన్ రావాలంటే దీన్ని ఎంతతో మల్టిప్లై చేసిందన్న 1/2. So that as it is, this is I think K2 na. K2 ని ఎంతతో మల్టిప్లై చేస్తున్నాం మనం? హోల్ పవర్ 1/2. నెక్స్ట్ ఇక్కడ అగైన్ ఏమొచ్చిందన్న, we have to find out the inverse value చేయాలి. సో 3A as it is కదా నోట్ చేయాల్సింది, as it is. సేమ్ D2A కాబట్టి 3B is equilibrium with 3A. ఈ ఈక్వేషన్ ఉంది కదా తల్లి, మనకి ఈక్వేషన్ వచ్చేసింది. మనకి ఈ ఈక్వేషన్ నుంచి ఓకే, మనం ఈ ఈక్వేషన్ కి వెళ్ళాలంటే ఏం చేస్తున్నాం మనం? మల్టిప్లైడ్ బై 3 నా? చిల్డ్రన్ టెల్ మీ. చెప్పండి అన్న. ఈ ఈక్వేషన్ రావాలంటే అంటే బి రావాలి అంటే దిస్ ఇస్ ఇంటూ 1/3 ఇంటూ 1/3. నౌ 3 cancel, 3 cancel. B is equal to B. Now as it is the K1 value multiplied with 1/3, so that whole power 1/3. Now K is equal to K1 whole power 1/3 into K2 whole power 1/2 into, so ఇంకేముంది మనకి, by K3. This is my answer. Is anybody doubt?
No
Is
doubts.
anybody? No doubt. Right, children, this is the effect of stoichiometric coefficients is also completed, and the inversion of the mode of the reaction, both applications is completed. Now let me go to the next one, that it is effect of temperature. Effect of temperature. Effect of temperature. Right, children, what is the effect? Note Kc or Kp must be affected by temperature. Children. Now simply Kc or Kp. Kc or Kp is equal to A into e power minus delta H by RT. Minus delta H by RT. Now, this is at a different temperatures now. If I am taking different temperature, then Kc1 is equal to, this is a T1. For that, by changing the temperature, Kc value is also changes. Kc value is also changes, children. How it will change? This is a Kc2. Kc2 is equal to A into e power minus delta H upon RT2. So divide the equation 1 from 2 and solving. Finally, I will get this log. Finally, from these equations, no derivation. Inka chesa about the 2 pages osastali. Finally, I am taking the one more equation. Log K2 upon K1 is equal delta H by 2.303 R into 1 by T1 minus 1 by T2. 1 by T1 minus 1 by T2. Now, in other words, log K2 upon K1 is equal delta H upon 2.303 R into LCM I am taking. T2 means T1 into T2 or T2 into T1. Sorry, T2 minus T1. LCM I am taking. This is T2 minus T1 by T1 into T2. It's clear. This is the equation. Now I am applying to the exothermic reaction and endothermic reaction. Reminder, children, this is a delta H is a enthalpy of reaction. Enthalpy of reaction. Now, this is a R is a universal gas constant. Generally, we are taking the R value gas constant 0.0821 gas constant. Right. So Kc is equilibrium constant. K1 is the equilibrium constant at T1 temperature. K2 is the equilibrium constant at T2 temperature. It's clear, children. For so reminder that here, so here T2 is greater than T1. Reminder, T2 is greater than T1. Right, children. So first case 1. Case 1. For exothermic reactions. For exothermic reactions. For exothermic reaction, children, delta H is negative. Delta H is negative. Now, delta H is negative and e part mottam emavutadi talli negative. Ante idi negative ante this is less than 0. Then log K2 by K1 is less than 0. It's clear, ma. Now, children, observe this one. Varshit?
Sir, you would explain that process again?
In ma?
మళ్ళీ ఒకసారి ఎక్స్ప్లెయిన్ చేయండి సార్.
Which one? This one, This one?
Yes, sir.
Yes. For the example, children, what I am taking, delta H is negative. This total term, delta H is negative. For example, for a exothermic reaction, delta H is negative. And the delta H value is negative. This total term becomes as negative. Then negative and less than 0 ne kada idi. E value less than 0 aithe ne kada idi. Negative and is less than 0 ne avutadi. So log K2 by K1 is less than 0. Now, on applying this logarithm value, okay, log A by B, log A by B means log K2 minus log K1 is less than 0. Is less than 0. Then taking of this one here, children, K1 is greater than K2 and applying this, then apply చేస్తే అంటే ఇవి రెండు ఇప్పుడు లాగ్ లాగ్ తీసేసాం అనుకున్నాను. ఇప్పుడు ఏమవుతుంది, ఇది టోటల్ వాల్యూ ఏమైంది, నెగటివ్ అయింది కదా. ఇలా దీని నుంచి ఇది సబ్స్ట్రాక్ట్ చేస్తే ఏమైంది, నెగటివ్ అయింది. నెగటివ్ అయినప్పుడు హైయర్ వాల్యూ నా లోయర్ వాల్యూ, టెల్ మీ.
Higher value.
Higher value.
Higher value, sir.
Right, so that K2 is lesser than K1. అంటే ఏం అబ్జర్వ్ చేసుకున్నా, టెంపరేచర్ రైట్ చేసేస్తే K వాల్యూ ఇంక్రీజ్ అవుతుంది. నీట్, ఇంపార్టెంట్ ఫర్ నీట్. ఫర్ exothermic reactions, K is inversely proportional to absolute temperature. Children, understand na?
సార్ నేను ఇందాక అడిగింది కిందది కాదు సార్, పైనది టెంపరేచర్ లాగ్ K2/K1 అది చెప్పమన్నాను.
ఇది డెరివేషన్ పార్ట్ నాన్న. ఇక్కడ నుంచి నువ్వు సబ్స్ట్రాక్ట్ చేసేసుకోవాలి. ఇక్కడ నుంచి దిస్ టోటల్ మనకి 1 పేజ్ వస్తుంది డెరివేషన్ చేయాలంటే. నెక్స్ట్ డెరివేషన్ స్టెప్ ఏమవుతుంది, నెక్స్ట్ డెరివేషన్ స్టెప్ ఈజ్ జస్ట్ రిమైండ్ దిస్ వన్ ఓన్లీ. ఇది మీకు సెకండ్ ఇయర్ లో వస్తుంది ఈ వాల్యూ. సో నేను ఈ ఈక్వేషన్ ని ఎలా కన్వర్ట్ చేస్తున్నానో చూడండి. సో లాన్ K, ఓకే, మైనస్ డెల్టా H by RT plus ln A. This is equation 1. Okay na? This is equation 1. Equation 2 ఏమవుతుంది, K1 తీసుకున్నాం అనుకో, this is next ln K2 is equal to minus delta H upon RT2 plus ln A. ఈ ఈక్వేషన్ నుంచి ఈ ఈక్వేషన్ ని సబ్స్ట్రాక్ట్ చేసినప్పుడు దిస్ వన్ మైనస్ దిస్ వన్ కదా అయ్యేది. అప్పుడు ఏమవుతుంది, లాన్ K2 మైనస్ లాన్ K1. ఈ లాన్ K2 మైనస్ K1 అంటే లాగ్ A మైనస్ B ఫామ్ వస్తుంది. అప్పుడు ఏమవుతుంది నాన్న, లాన్ K2/K1 అవుతుంది. ఇక్కడ ప్లస్ దిస్ ఇస్ ప్లస్, దిస్ ఇస్ మైనస్, ఈక్వేషన్ మైనస్ సబ్స్ట్రాక్ట్ చేస్తాం కాబట్టి ప్లస్ LNA మైనస్ LNA క్యాన్సిల్. డెల్టా హెచ్ఆర్ కామన్, వీఆర్ టేకింగ్ డెల్టా హెచ్ఆర్ కామన్. ఇది మైనస్ వాల్యూ, మైనస్ ఇంటూ మైనస్ ప్లస్ వాల్యూ అవుతుంది. ఓకేనా? సో అప్పుడు ఏమైతుందన్న మనకి డెల్టా H/R ఇంటూ, ఓకే, దిస్ ఇస్ 1 బై కామన్ కదా, T 1 బై లో ఉంది కదా, 1/T1 minus 1/T2 on solving this. ఈక్వేషన్ సబ్స్ట్రాక్ట్ చేస్తే వచ్చింది నీకు ఇదే. లాన్ పోవాలంటే ఏం చేస్తాం మనం, లాగ్ బేస్ 10 2.303 లాగ్ బేస్ 10 K2/K1. ఈ 2.303 ని క్రాస్ మల్టిప్లికేషన్ తీసేసుకున్నాం. అప్పుడు ఏమైంది, 2.303 R లాగ్ K2/K1, లాగ్ K2/K1 delta H, okay, 2.303 R into T1 by 1/T1 minus 1/T2. Clear now? It's clear. Ashwit,
Yes sir, clear.
right. Now this is the case of exothermic reaction. In case of exothermic reaction, what we have to take? Right. Now, for a endothermic reaction, case 2. Endothermic reactions. For endothermic reaction, what will be happening? So, for a endothermic reaction, delta H is a negative. Sorry, delta H. Yes. Delta H is a positive, means greater than 0. So apply this one, log K2 by K1 is equal to, is greater than 0. It's clear now? Clear? ఇందాక ఏమైందన్న లెస్ దాన్ 0 అయితే ఇప్పుడు ఏమైతుంది గ్రేటర్ దాన్ 0 నే కదా అయ్యేది.
Yes,
డెల్టా
sir.
హెచ్ పాజిటివ్ అయిందంటే ఇట్స్ వాల్యూ కంపల్సరీ పాజిటివ్ కదా అవ్వాల్సింది. ఇట్స్ వాల్యూ పాజిటివ్ అయితేనే కదా దీనికి ఈక్వల్ అయ్యేది. దెన్ ఈస్ గ్రేటర్ దాన్ 0. అప్పుడు ఏమైతుంది నాన్న, లెట్ మీ టేక్ దిస్ వన్ is greater than 0. Now again I am taking log K2 minus log K1 is greater than 0. In that situation, okay, K2 is greater than K1. Now K2 is greater than K1. In this case, in the previous case is K2 is less than K1. So as rising the temperature, K2 is also increases. So that for a neat equilibrium constant, that it is K is directly proportional to temperature. It's clear now, children? Clear now? Right. Now these are the factors especially affecting the equilibrium constant. Now let me discuss about the some other factors. Other factor is effect of concentration. Effect of concentration. Concentration of reactants or products do not affect the K. K means either Kc or Kp, children. Do not affect. For the example, what I am taking, children. For a gaseous reaction, 2A plus 3B is equilibrium with 2C plus 1 by 2D. Kc is 4 into 10 power minus 2. Okay. If concentration of A and B are doubled, then Kc is then Kc is
Kc
Same.
hmm?
Same.
remains unchanged.
Very good. So correct answer. Kc is this is 4 into 10 power minus 2. Okay, means no change. Special point is Kc or Kp, not by. Kc or Kp do not depends on does not depends on concentration of either reactant or products. It's clear na children? Children, it's clear now. Tell me.
Yes, sir. Yes, sir.
Right. Now, effect of catalyst, the next one is effect of catalyst. Catalyst. In the similar manner, catalyst do not change the catalyst does not change the value of sorry children, sorry. Of course, catalyst is also does not change. Okay, catalyst is also do not change the Kc value. Effect of catalyst. Okay. Now, last factor is the addition of inert gas. That it is addition of inert gas.
Sir,
Ma.
sir, does it affect Kp, sir?
Ma.
Catalyst affect the Kp value, sir?
No. Kc or Kp. Both. Okay. Addition of inert gas. Right. By addition of inert gas to the equilibrium mixture, by addition of inert gas to equilibrium mixture, it does not affect the Kc or Kp. For the example, N2 plus 3H2 is equilibrium with 2NH3 at a certain temperature. Kc is 2 into 10 power minus 1. Okay. Now, to this reaction mixture, 2 grams of helium is added. Then Kc, then the value of Kc is, my answer is same, no change, that it is 2 into 10 power minus 1. Children, clear now? It's clear now?
Yes, sir.
Right. These are the factors that affecting the Kc and Kp. Ma, Miku, homogeneous, heterogeneous completed, factors completed. Okay. Now then let me solve some model problems regarding the determination of Kc or Kp value, children. Different models let me have to solve in this class. Right. Right. My problem is Kc for the reaction that it is N2 plus O2 is equilibrium with 2NO is 100. So what is the Kc of reaction NO is equilibrium with 1 by 2 N2 plus 1 by 2 O2 is solve the problem, children.
minus 50, sir.
Minus
50.
10.
10 possible. Next,
Sir, minus
only
50.
2 members.
Same.
120 now.
Minus 50. Minus 150. See, minus 50. Sir.
Minus 50.
50.
50. Banu, what is your answer?
Minus 50, sir.
Minus 50.
Sir, 1 by 10.
Ma? 1 5, huh?
1 by 10, sir.
1 by 10. Right. Now I am solving the problem. For this equation is reversed. So Kc ఏమనుకున్నాం తల్లి మనము Kc is equal to 100 అనుకున్నాం. దీనికి ఏమనుకుంటున్నాం తల్లి మనం Kc dash. So both are inverse na. So Kc dash is equal to 1 by Kc. But this equation to get this equation, equation నుంచి ఇది రావాలి అంటే ఏం చేయాలి తల్లి multiplied by 1 by 2. 2 to cancel. So multiplied by 1 by 2 now, multiplied by 1 by 2. So that whole power 1 by 2. 1 by 2 means, what is your answer? 1 by 100 whole power 1 by 2. 1 by 10 square whole power 1 by 2. 2 cancel. 1 by 10 is equal to 0.1. Is our answer. Clear now?
Yes, sir.
Right. Next problem. Equilibrium concentrations of SO2, O2 and SO3 are 0.5, 0.25 and 0.25 respectively. Right, children. Find Kc of 2SO3 is equilibrium with 2SO2 plus O. Okay. ఈ రియాక్షన్ కి మీరు ఏం ఫైండ్ అవుట్ చేయాలి? కేసీని ఫైండ్ అవుట్ చేయాలి. How to solve the Kc value? Okay, my answer is Kc is equal to active mass of sulfur dioxide. Its stoichiometric coefficient is raised as their power according to law of mass action. O2 upon SO3 whole square. Right, children? Now SO2 concentration is SO2 means 0.5. So that 0.5 into 0.5 square means it 0.25 upon 0.25 whole square means 0.25 into 0.25. 0.2525 cancel. How many times ma? 2 times is equal to 1 is the answer. Okay na? ఒకవేళ యూనిట్స్ అడిగాడు అనుకున్నాను. యూనిట్స్ కాన్సంట్రేషన్ క్యాన్సిల్. Sorry. Concentration square cancel. Concentration will be remain. Means 1 mole liter mass. Children, understand how to solve the problem. ఏమైంది ఈరోజు అందరికి?
Understood.
Children, yes. Copy now?
Yes, sir.
My next problem is at a certain temperature, a 10-liter vessel, contains 0.4 moles of H2, 0.4 moles of I2 and 0.1 mole of HI is there. Okay, find Kp of H2 I2 is equilibrium with 2H. Reaction is
0.0625.
0.0625. Okay, very good, ma'am. Very good. Is anybody solved the problem? Question is asking about the Kp value. For this reaction, delta N is equal to 0, so that Kc is equal to Kp avutadi. No problem. Total pressure is not given, then number of moles is taken as the partial pressure. Number of moles is taken as partial pressure. Now my equation for this one is H2 plus I2 is equilibrium with 2HI. Okay, as vessel containing the these are the number of moles is considered as the partial pressure. It's clear. Now that Kp is equal to HI square 0.1 into 0.1 upon I2 is 0.4 and H2 is also 0.4. Means 0.4 into 0.4. 0.01 upon 0.16. That it is 0.0625 is our answer. Delta n is equal to 0, no units. Children, it's clear now?
So once again, can you say?
Yes, yes.
So question is directly asking ma, నువ్వు కేసీ క్యాలిక్యులేట్ చేస్తే కేపీ వచ్చినట్లే మీకు. ఎందుకంటే మనకి టోటల్ ప్రెజర్ ఇవ్వలేదు అండ్ ఆల్సో కేసీ ఈజ్ ఈక్వల్ టు కేపీ అండ్ డెల్టా ఎన్ ఈజ్ ఈక్వల్ టు 0. సో దట్ ఇప్పుడు నేను కేసీని క్యాలిక్యులేట్ చేస్తున్నాను అనుకోండి. కేసీ క్యాలిక్యులేట్ చేస్తున్నాను. కేసీ క్యాలిక్యులేట్ చేసేటప్పుడు ఏముంటుంది తల్లి? దిస్ ఇస్ ద నంబర్ ఆఫ్ మోల్స్ బై బేషల్. దట్ ఈస్ 0.1 upon 10 into 0.1 upon 10 upon. So its number of moles. This is the HI na? Okay, HI completed. Now H2 concentration. H2 means how many moles? 0.4 upon 10 into its concentration is 0.4 upon 10. Now on cancellation, what did we cancellate this? By 10 into 10 by 10 into 10 cancel. Now again ide kada vachedi niku 0.01. Okay, then on solving this we are getting this value. Kc is equal to kp kada. If you are solving the kc value, then you get the kp value. Why? Because delta n is equal to 0. Rakesh, understand na?
Yes, sir.
Right. Now I am going to the next problem, children. Similar model I am giving, solve it.
Sir, when delta n is not equal to 0, sir.
Appo data వేరేలా ఉంటది.
Okay, sir.
Now problem what I am giving, children, that it is for a reaction N2O4 to NO2, gaseous and gaseous. Equilibrium concentrations of N2O4 and NO2 are 0.2 and 0.1. Then find Kc.
0.05, sir.
Very good. 0.05. Let me solve the problem. Right. Right, children. So for this equation, question is asking about Kc is equal to at 2 mass of already equilibrium concentration se problem lo direct ga ichadu manaki. Equilibrium lo unna concentration similar. This is its concentration is 0.01.